What's up, everyone? Today we're going to take a quick look at magnetron sputtering and explain the process, as well as demonstrate how to deposit a thin film of metal.
So now we'll take a quick look at the sputtering system using a two-gun example.
We have two guns on the bottom. They just as well could be on the top. It does not really matter. It's just a system configuration. So in order to sputter, what we need to do is first evacuate this chamber. So typically we'll pump this down to something in the low 10 to the minus 6 torr range. And then we will introduce a sputtering gas, and the most common one is argon. So we flood the chamber with argon, and then we can apply an electric field across the cathode and the anode, and this electric field just needs to be sufficient to ionize the argon, and that will create the plasma. So once we have the ionized argon atoms, we can then accelerate them towards a target in the electric field. And once we have the ionized atoms strike the target, that will eject the target material, and that's how we can create a thin film coating. And then one way to go further with this is to introduce the magnetron. So by introducing magnets here, we can actually take advantage of the interaction between electrons and a magnetic field, and we can create a high density plasma. And this is going to increase the target bombardment and therefore increase your deposition rate. So when looking at the sputtering system here, there's essentially two chambers. One, the main chamber, and the other being the load lock. The load lock is a really nice way to introduce your sample into the chamber without having to vent the entire chamber. Once the sample is introduced to the load lock, it is then pumped to high vacuum. Once it is under high vacuum, we can then open the gate valve and transfer the entire sample platen into the main chamber. At this point, we can now program our recipe. This typically includes setting parameters such as sputter time, sputter power, substrate rotation speed, and gas partial pressure. Once the process begins, we can now observe the plasma, which is the argon ion striking our target and depositing our film. Once the process is over, we can then open the gate valve and transfer the sample platen back into the load lock. At this point, we can close the gate valve and vent and remove our samples. And this leaves us with a nice uniform metal coating on our substrate.